Hey everybody. Today we're going to talk about the remainder theorem. Okay, so we'll be looking at pages 18 and 19 of your Unit 10 packets. All right. You're going to want your calculator handy for this, that's for sure. Let's take a look at what's going on. In the last section, we saw how to divide a couple of polynomials, and that would result in a quotient and a remainder. They're saying it resulted in another polynomial, but that was the quotient part, and a remainder. The remainder has a remarkable property in certain types of division. That's what we're going to explore in this first exercise. Consider each of the following scenarios where we have some polynomial, p of x, divided by x minus some number we're going to call a. In each case, simplify the division using polynomial long division, and then look what happens when you evaluate the original polynomial, the thing in the numerator, at x equals a. All right, so let's see what's going on here. In the first case, we'll use some long division. These will be quick. X times x is x squared. Distribute the x. Subtract. Negative 8. Well, the x squareds cancel. Negative 8 minus negative 2, negative 6. Bring down the 18. Okay, x times negative 6. Distribute. Here we're going to get a plus 12. And it looks like the remainder is going to be 6. Okay, so this equaled x minus 6 plus the remainder over the original divisor. All right, well, now what they're asking us to do is, well, see what this actually equals when we plug in positive 2. Notice we divided by x minus 2, x minus a. See what happens now when we evaluate at that x value we call a. All right, so if it's x minus 2, let's see what happens when we actually plug 2 into this thing. All right, this is where, just use your calculator to make life easy. But if I plug 2 into this, I get back 6. Okay? Well, what do you notice? That's exactly what our remainder ended up being. Okay? Let's take a look at the next example. All right, same idea. We'll do a long division here. Okay, x times x, distribute. Okay, negative 2 plus 7 is 5. Bring down the 25. Okay, x times 5 is 5x. Here, careful subtracting. It looks like the remainder is positive 10. So this thing equaled x plus 5 was our quotient plus the remainder over the original divisor. Well, let's see what happens when we plug 7 into this thing. So 49 minus 14 minus 25. Well, holy moly, it equals 10. We divided by x minus 7, we got a remainder of 10. When we plugged in positive 7 to the original function in the numerator, we also got back 10. Right? So you should be seeing that there's a relationship between our remainder. When we divide by something, there's a relationship between what we get back for the remainder and what we get back if we plug in that value of x, okay, that we divided by. If it was x minus 7, we plug in positive 7. If it was x minus 2, we plugged in positive 2. Okay, a couple more examples. All right, here. Okay, x times 2x this time. Okay, here we're going to get 5x, bring down the 11, and we're going to need x times 5 to get to 5x. And here it looks like the remainder is negative 4. Okay, and then if we plug this in, let's see what happens when we plug negative 3. And notice it was x plus 3 in the denominator, so that's why we're using negative 3 this time. So 2 times negative 3 squared plus 11 times negative 3 plus 11. Sure enough, negative 4. All right, so again, the remainder and what we get when we plug in kind of that what I call the opposite value of x, right? X plus 3 we divided by. If I plug in negative 3, I'm getting the same value back. Okay, one more of these to go. X times 3x is 3x squared plus 12x. 7 minus 12, negative 5x. Bring down the 20. X times negative 5. Distribute the -5. Oh, and here we're going to have a remainder of 0. So what do you think is going to happen now we divide it by x plus 4? What do you think is going to happen if we plug -4 into this thing? I'll take a second to do it. And sure enough, you get back 0. Okay? And this leads us to basically the idea called the remainder theorem. When a polynomial is divided by a linear factor of the form x minus a, okay, that's what these are, x to the first power, that's why they call it a linear factor. Okay, the remainder will always be the same as if you evaluated the polynomial at a. In other words, okay, if we take our polynomial and divide it by x minus a, we get back our quotient plus the remainder over x minus a. So what they're saying is the remainder is always equal to whatever the polynomial evaluated at x equals a is. Okay, that's the gist here. Okay, that's the remainder theorem. So let's take a look. In number 2, we have x squared minus 11x plus 22 divided by x minus 9. Well, if we divided that out and put it in the form of quotient plus remainder over the x minus 9 we were dividing by, okay, where q of x is a linear function, then which of the following is the value of r? All right, so again, r is right here. We're looking for r. We basically want to know what is the remainder. So we could go through what we've been doing, divide this out, figure out what the remainder is, or we can try to now apply the remainder theorem, which is even quicker. So if I want to know what the remainder is, if I'm dividing by x minus 9, I'm going to look at what this polynomial in the numerator is at x equals positive 9. So let's see what we get back here. We're going to have 9 squared minus 11 times 9 plus 22. So what do we get back here? We get back 4. Okay, which is an answer choice, and there you go. So again, if you want to verify it, use long division, but now we have this technique to figure out what the remainder is without actually going through the long division process. Okay. In the past, the remainder theorem was used primarily to aid in evaluating polynomials. These days, it is the primary justification for telling if a linear expression is a factor of a polynomial. Remember, if something is a factor, we kind of talked about it in page 17, what's the remainder going to be? 0, exactly. All right, so by definition, x minus a is a factor of a polynomial if, when we take the polynomial and divide by x minus a, we get back a quotient, right, where q of x is just some other polynomial. Well, what must be true of the remainder for this to be a factor? Well, we just said the remainder will equal 0. There is no remainder if it's a factor. Okay, so if when we divide by x minus a, we get a remainder of 0, and the remainder is found by p of a, well, that means that p of a itself will equal 0. And that's kind of what we care about here. We can determine if something's a factor by looking at p of a. If that equals 0, then we know it's a factor. So let's take a look at these problems down below here. Part A, is x minus 3 a factor of this? So what I'm going to do is evaluate p of 3. If it equals 0, then yes, it's a factor. If it doesn't, then no, it isn't. So let's see, 9 minus 33 plus 24 ends up being 0. Yes, x minus 3 is a factor because p of 3 equals 0. Okay, next one, part B. Is x plus 5 a factor? So I'm going to look at the value of p of negative 5. So let's see, again, just punch that in. And here I am getting a value of 3. So that means that if I divide it by x plus 5, there would be a remainder of 3. And since the remainder is not 0, not a factor. Okay, part D. Is x plus 1 a factor? So what are we going to plug in? Negative 1. Let's see. And that equaled 0. So yes, it is a factor. And last but not least, is x minus 5 a factor of this other polynomial? Let's plug in positive 5 and see what we get. And I am getting back negative 5, so it's not a remainder of 0. It is not a factor. All right, and last up here, for what value of k will x minus 4 be a factor of x squared minus kx minus 52? So we're basically solving for the, that term in front of x, that number in front of x here. Show how you arrived at your answer. All right. Well, for what value of k will x minus 4 be a factor? Well, think about it. If x minus 4 is a factor, what's going to be true when I plug positive 4 into this thing? That's right. It will equal 0. Okay, so p of 4 equals 0. So what I'm going to do is I'm going to plug 4 in for x, and we'll set the whole thing equal to 0. So we get 16 plus 4k minus 52 is 0. Let's see, 16 minus 52 is negative 36. 4k minus 36 is 0. 4k is 36, so k is 9. All right, if k is 9, then x minus 4 will be a factor. Let's check that. Let's see, x squared plus 9x minus 52. Is that going to equal x minus 4 times something? X plus 13. Yeah, that works out. Look at that. Okay, so k equals 9. All right, so you guys try the next 2 pages for homework. I'll make a video going through those solutions, and you can check your answers. All right.